for a second. Okay, so let's talk about verifying. What does it mean to verify something, right? It means to prove that it's true or not, right? To validate it, to validate the statement. So when we shift from simplifying to verifying, there's one really important, structurally the difference is now we see an equal sign, okay? Whereas before, the problem would have just been this or this on the page, and it would have said simplify. And then you're just going to work with the tools and simplifying to get to here. When we talk about verifying, here's why verifying, I say, it's easier, but also has more traps, if I could say, put it that way. It's easier because it's telling you, the way that the problem is set up is it's telling you what you should end up with, right? Part of the problem with simplifying is you never know if you're done. You don't know if you've actually simplified it as far as you could, okay? This is giving us a target and saying, when you simplify this, you should get this, or vice versa. If you want to simplify that, you should get that, okay? So that's what makes this a little bit different and easier, but it's super misleading because of that equal sign. If they really wanted to set you up for success in these textbooks, there would be a question mark above that equal sign, okay? Because we're supposed to be verifying. What this statement should be saying is, I'm not sure if this is equal to that. Can you please prove it for us? And that's when I told you we were doing proofs. These are proofs, okay? Prove that that is the same as that. So that's our job. And all we're going to do is the same stuff we've been doing, okay? But we're going to do it one side at a time, okay? And in the end, when we're done, we'll have a statement with the exact same thing written on both sides of the equal sign. All right? So that's what verification is. We're going to go through the simplification process. We'll probably do this side. And then we might not have to do anything over here. Okay? And then when we're done, we will have the same thing on both sides. And then we'll put a check mark and we'll say, ta-da, verified. Stamp of approval. Now, the one thing you have to keep in mind when you're verifying, and again, this is what I say this is what I mean when I say it's misleading. That question mark isn't going to be there. So you're going to look at this and you're going to say, okay, I'm going to solve this equation. And when you start thinking that you're solving an equation, you might look at this at some point and say, I'm going to multiply by sine x. So I can get rid of that. And multiply by sine x over here. Because if I do that, and there's going to be stuff that we can do over there. Here's the thing. You can't do that. All right? And again, I told you we were going to get philosophical. When you were in geometry, and you were doing two-column proofs, okay, you would have learned about the properties of equality, the addition property of equality, the subtraction property of equality, the division property of equality, blah, 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 blah. And those are the rules that we use when we solve equations, okay? The addition property of equality says, if A equals B, then A plus C equals B plus C. It more or less, this is what it says. Right? But it starts with this condition. It starts with the condition that you know for a fact that these two sides are the same thing. And if they are the same thing, then adding the same value to both sides still produces an equivalent statement. Okay? That's the addition property of equality. A subtraction, multiplication, division, same thing. That's what we use to solve equations. Are these properties of equality? But again, I emphasize the point that they start with that assumption. We know these two things are the same. Therefore, that's not what this is saying. This is saying prove that this is the same as this. So, here's where it's tricky. If you multiply both sides here by sine x, you're gonna get a statement that's equal. Because they're not gonna give you something that can't be proven, if you're wondering. So it's always gonna work, but you can't do it. You can't multiply, subtract, add, divide, none of that to both sides of the equation. You have to fight that urge, even though you see this equal sign. Okay? So, how do we verify? We simplify, and then at the end, we have a statement that with the same thing on both sides. Does that make sense? Okay?
I think it's true.